In this video, I will demonstrate how to use the Claim Variability Benchmarks product to benchmark an unpaid claim distribution. To set the stage a bit, an unpaid claim distribution can be used in a variety of risk management situations, such as setting up risk margins, assessing risk-based capital, and evaluating reinsurance, among other uses. For each situation, the data you use needs to fit the goals of the modeling exercise, and then the next issue is selecting a modeling framework that will fit your goal. But the real issue is that even theoretically sound models tend to underestimate the distribution of possible outcomes because the data used in the model can't possibly include enough of the possible outcomes. Finally, a question you might be asking yourself is whether this type of benchmark can be customized to your data. With that bit of background, I'll start the demo by opening an example. As a common starting point, you can see on the screen now that I just have a paid-loss triangle, and I'm going to use the ODP Bootstrap with the paid chain ladder model. So I've set up some diagnostics here. We've added some hetero adjustments. And then after I ran some simulations, I ended up with these unpaid claims and this nice distribution. So on the surface, it looks reasonable. So the question becomes, how do we benchmark this? And because I also want to demonstrate that we don't have to just use one model, I've actually set up 4 models for the same data set, both paid and incurred chain ladder and BF models for the ODP Bootstrap. And you can see the results vary a bit. The means jumps around. The standard deviation jumps around. So this maybe calls into question which model is the most reasonable, which one would you want to use, how would you want to weight these together, all those kinds of things. So that's where the benchmarking really comes into play. So here now I've opened up Excel with the template open. And on the input page, the typical thing we need to do is make sure we select the line of business. In this case, it's commercial auto, so we're good to go. And the only thing I need for a benchmark is to enter the premiums and the expected loss ratios. So now I've pasted in the premium and the operating loss ratios for this particular data set and the modeling I've been doing. Now I can go to the unpaid tab and I can see the initial benchmark and compare it to any of the models. So let me open those up on the screen too. So here I've moved in the windows for the paid and incurred chain ladder models for the ODP Bootstrap, and I can compare the mean of 12.9 with 8.5 and 16.9. So you can see that the two models aren't necessarily converging yet, but we don't have a valid comparison yet because there aren't any tail factors in here, which leads us back to our first customization. So moving back to the inputs page, the first other option I want to look at is using a selected development pattern. Now, since this is a standard ODP Bootstrap model, I've just plugged in the volume-weighted average age-to-age factors, included a tail factor, and after scrolling down, I just selected this as a user input pattern. I just selected the volume-weighted average pattern so it exactly matches the model. And now scrolling back up, I'm going to go ahead and turn this option on. So I'm going to use the selected pattern. Now switching to the unpaid page to see the result, you can see that the mean has gone down a little bit because I now have the average pattern in there. But the takeaway here is that the benchmark is telling us that the mean is likely between the two models, whereas in both cases, the standard deviation is likely to be underestimated. We can also use the benchmarks to assess the assumptions of all the models we're using and to inform our decisions on the weights. But the next customization would be to shift the benchmark to match our best estimate of the mean. So we can paste in our best estimate of the mean and turn shifting on. I can use additive or multiplicative shifting, but in this case I'll use additive. So now that we're back on the unpaid sheet, we can see that the mean has indeed shifted to match our estimated and the standard deviations have not changed. And since we've added a tail, we can manually enter a standard deviation for the tail, which could be based on our modeling. For this demo, I'm just going to eyeball it and enter 50. And as you can see, this does increase the overall standard deviation a bit. Once you have the benchmark, you can scroll down and you can see that there's also, as part of this, calendar year cash flows, the runoff, and in fact, loss ratio variations that you could use for various risk management purposes. Based on the backtesting used to create this product, it is more likely to find the benchmark indicates the need to increase your standard deviation. However, while less common, it is certainly also possible to end up with a smaller indicated standard deviation. In either case, this has significant implications for your risk metrics based on the tail of the distribution. So I hope you benefited from watching this demo. You can find more information on our website, including an article that digs deeper into creating unpaid claim distribution benchmarks. And you can also send me an email, and I will be happy to help you learn more about benefiting from the claim variability benchmarks.